Okay, so the next one is O is the origin, P is the point xy, is a point on the curve y equals 4 over x, where x is bigger than 0. The length OP is the distance from the origin to P. Now this can be any distance, like it can be, as we change the value of x and y, so does the distance change as well. Okay, now express OP in terms of x. Well, OP we can get by a right angle triangle. X is the x distance, this one's the y distance, and we find the distance d. Okay, so OP squared equals x squared plus y squared. We want x only. Y equals 4 over x. This means that y squared equals 16 over x squared. This makes the answer for OP squared equal to x squared plus 16 over x squared. We can find a common denominator there. We can put another x squared here on the bottom. We can get x4 plus 16 all over x squared for OP squared, and then square root both sides, and we can say that OP ends up to be the square root of x4 plus 16 all over x squared, and that can be the square root of x squared plus 16 all over x. Okay, now okay, so we've done that successfully. Now what we're looking to do next is given that there is one value of x for which OP is a minimum, find this value of x. Okay, so what we're going to have to do is going to have to differentiate this. Okay, and I've got to call it a letter. I'm just going to call it L. Alright, so L equals x4 plus 16 to the power of a half, and this is x on the bottom. So what we're going to do is we're going to get dl dx. Okay, so dl dx should tell us when it's going to be a minimum. Okay, so remember, minimum means turning point. Okay, so what we're going to do is we're going to differentiate this using the quotient rule. So we're going to get dl dx ends up to be, so u is x4 plus 16 to the power of a half. Remember how to differentiate this. It's a chain rule. The half goes to the front. Then it's x4 plus 16. Take 1 away from the power, you get to the power of minus a half. And there's also one other little bit. The other little bit you gotta do is you gotta differentiate what's in the brackets, which is going to be 4x cubed, and 16 turns to 0. Half the 4x cubed, because you gotta divide it by 2, and you get 2x cubed. So this answer here is going to be 2x cubed multiplied by x4 plus 16 to the power of minus a half. Now, v equals x, therefore dv dx equals 1. Now we're going to put it all into the formula here, and we're going to try and figure out what exactly to put in here. Okay, so that's what we're doing here. So what we're going to do is we're going to do the quotient rule now, and let's see what happens. Okay, so the quotient rule: phi times the u dx minus u times the v dx all over v squared. So let's find out what we're getting. So phi times the u dx is going to be x times the u dx, which is going to be 2x cubed x4 plus 16 to the power of minus a half. Okay, and then what we're going to get next is we're going to get minus u times the v dx, which is minus, so u times the v dx is x4 plus 16 to the power of a half times the v dx, which is 1, all divided by x. Now what we're going to do right away is we're going to get this x squared plus 16 to the power of a half minus a half, and we're going to move it onto the bottom. So it's going to be x power 4 plus 16 to the power of a half. Now what we can also do here, because this one doesn't have a denominator either, what we can do is we can multiply top and bottom by the same denominator here. So we're going to get x4 plus 16 to the power of a half divided by x4 plus 16 to the power of a half. Now what that's going to create, it's going to create 2x4 on top. Then this one here, when the two of these multiply by each other, they make one of them, so it's going to be x4 plus 16. And then on the bottom, we're still going to have x4 plus 16 to the power of a half, all divided by x. Now, what we need to do next. Okay, so what we're going to do is when we have a fraction divided by a number, what we do is bring the number up and we turn it upside down. Okay, so what we're going to get here is we're going to bring this up and turn it upside down, so it then becomes 1 over x. Okay, so what we're going to do is we're going to get 2x4 minus x4 is going to be x to the power of 4. And then it's going to be minus 1 times 16 is minus 16. All over x bracket x4 plus 16 to the power of a half. And when you differentiate, it has to be equal to 0. Okay, so we're going to, when we cross multiply that all up, it disappears, so we're going to be left with x4 equals 16. X therefore must be equal to 2. We now know that x is equal to 2. It's the only answer, therefore it's the only turning point, and if the question says it's a minimum, therefore it should be a minimum. Now we're going to find the length of OP. Well, the length of OP is going to be this one here, which is going to be 2 to the power of 4 plus 16 all over 2, which is going to give me the square root of 32 over 2. So root 32 over 2 divided by 2, and the answer is going to be 2 root 2. So the answer for that is going to be 2 root 2. Okay, number 29. A right circular cone with base radius r and perpendicular height h has a slant height of 10 root 3. Express r squared in terms of h squared. Okay, well, we can use Pythagoras' theorem. And we say that h squared plus r squared equals the slant height squared, which is going to give me h squared plus r squared equals 100 times 3, which is 300. Therefore r squared equals 300 minus h squared. Done. If to find out the cone's maximum, find the perpendicular height and b the radius. Okay, well, the volume of a cone is a third pi r squared h, and what this is going to be is a third, we're going to replace r squared with h, so we're going to get third pi 300 minus h squared times h, and what this should turn into is, we'll bring the h to the front and put it in here, and then we're going to multiply it out. So we're going to get a third into 100, a third of 300 is 100, so we're going to get 100 pi h minus 1/3 pi h cubed. We're then going to differentiate, sorry, that's still v. Next step is we're going to differentiate the VDH, and what we should get here, because it says a maximum, doesn't it? To be a maximum, find its perpendicular height, right? So we've got to find out what h is, differentiate, and 100 pi goes through, and the h disappears. Okay, then you're going to bring the 3 to the front, multiply by a third, and what we get is minus pi h, take 1 away from the power, and when we do this we get pi h squared. Now this equals 0, the pi's will cancel, we're going to get h squared equals 100, therefore h equals 10. 10 is the only answer, And if we were to differentiate a second time, we'd end up with d2v th squared ends up to be minus 2 pi h, and h equals 10, which gives us minus 20, hence a maximum, because it's smaller than 0. The second root is smaller than 0, it's a maximum. Now h equals 10, therefore I need to find out what r should equal. R squared equals 300 minus 10 squared, because that's what h is. R squared equals 200. R equals the square root of 200. Square root of 200. 10 root 2. So 10 root 2 and 10. Okay. Move on to the last one here, which is 31. Cylinder is inscribed within a sphere of radius 3. The cylinder has a radius r and a height 2h. Express r squared in terms of h. Okay. So what we can say is that okay, so what we're going to decide here is that this here is the center, it's 2h, but it's going to be the center of the circle is going to be the center pretty much of the cylinder as well. So this is going to be h. We have a right angle triangle. We have h squared equals 3 squared plus r squared. R squared equals h squared minus 9. R is 9 minus h squared. Oh, sorry, wrong way around. 3 is the longest side, 3 squared equals h squared plus r squared. And then it's going to be 9 minus h squared equals r squared. Find the value of r when the volume of the cone is a maximum. The volume of a cone is a third. Now you got to remember its height is 2h, so it's going to be a third pi r squared h, but h in this occasion is actually 2h, so we've got to replace that with 2h. That's what the volume is. So it's going to be, volume is going to be 2 over 3 pi r squared h for this particular cone. We need it to be a maximum, so we're going to differentiate the v dh. Oh wait, we also have to substitute in one of them. We want the value of r, so we gotta get rid of we want the value of r. So what I'm gonna do is gonna get rid of r squared. So I'm gonna get the VDH. Still on v actually, excuse me. V is gonna equal 2/3 pi times what's it, 9 minus h squared times h. So v therefore is going to be equal to bring the h to the front, multiply 9 by 2 pi, we're going to get 18 pi h all over 3. 3 and 18 goes 6 times, so we don't need to worry about that there. We just put in 6 pi h, and then minus 2/3 pi h cubed when we multiply them out. Now we're going to get the VDH, and the VDH is going to be 6. Differentiate this with respect to h. The 6 pi goes through, the 3 goes to the front, multiplies by 2 over 3, and we're going to get minus 2 pi h squared. This all has to equal 0. The pi's will cancel. Okay, when that happens, so we'll just solve it now for a second. So what happens is we're going to get 2 pi h squared equals 6 pi. Pi's will cancel. Divide by 2. H squared equals 3. H therefore equals root 3. Now we found out what the height is. We know h squared equals 3. Then we can find out the maximum r. So 9 minus h squared. H squared is 3 equals r squared. R squared equals 6, therefore r equals square root of 6. Find the value of r when the volume of the cylinder is a maximum. Just let's make sure it's a maximum. We'll differentiate the second time. So when we get d2v dh squared, this 6 pi is a constant number, turns into 0. Bring the 2 to the front, we get minus 4 pi h. H is a positive number, so it's going to be minus 4 root 3 pi. This is a smaller number than 0. Therefore, it's a maximum as predicted in the question.